Hello everybody. I just want to make a quick little educational video here to clear up a misconception, or properly two misconceptions, that I see a lot regarding LACP, or the Link Aggregation Control Protocol. So, for anyone who doesn't know what it is, LACP is a low-level Ethernet protocol designed to combine multiple Ethernet connections, or Ethernet ports, links, whatever you want to call them, together into one logical link that both has failover and redundancy properties. You can lose one link and it will still stay up. But also, and importantly for these misconceptions, a performance benefit. And you'll get, load balancing and a speed aggregation. Now, this misconception I've seen absolutely everywhere. This video was triggered by a YouTuber I saw talking about connecting his server and his desktop together with dual 10 gig ports and LACP bonding, and, expecting higher performance. And, I've also seen it from big YouTubers like Linus Tech Tips. I've seen it from Reddit Our Home Lab. I've seen it from enterprise server admins even, and enterprise network admins, as scary as that may sound. This misconception is everywhere. And really, as I said, it's two misconceptions, but it's one misconception. Really, fundamentally, the misconception is around how LACP works and how it actually, decides where to send traffic. And it manifests as two very closely related but seemingly different misconceptions that people have regarding, putting, quote-unquote, putting ports together on their servers. The first misconception is that having two servers, or a client server, two machines, and having them have these bonded interfaces, with a higher aggregate speed, means that they will actually be able to get that higher aggregated speed. They won't. Between any two machines, you will only ever get one port's worth of speed. And I will demo that in a second to prove that that's what's happening. The second misconception is that if you have a machine with more than two Ethernet ports, that if you combine many Ethernet ports, say 4 10 gigabit ports together, that you'd get a 40 gigabit port and that you get 40 gigabits of total aggregate bandwidth. That's not true. You will only ever get, on aggregate, not just to one client, which is the first misconception, but to many clients, you'll only ever get the speed of 2 ports. So let's quickly demo the first misconception. So I have, my two servers here. They both have dual 10 gig ports in an LACP bond together. I can show Eth-tool on both. Both report, this 20 gigabit per second fake number here. And over on the right, I have the JNet top tool running, which just shows the overall, bits per second being transmitted. Full disclaimer, this tool has a bug. It won't show more than 2.25 gigabits of traffic, but that doesn't matter. I'll still make my point. So if I do iPerf server on the second server here, and if I do iPerf client and I run it, you'd expect to see 20 gigabits, right? No, I don't. I see 10 gigabits, 9.3435, somewhere in that neighborhood, 10 gigabits minus protocol overhead. And if we look over on the right, we'll see that, the first slave interface here is transmitting a lot of data. It's transmitting, this says 2.3 gigs, but it's that. If we look at the second slave interface, it's barely transmitting anything. This is just some background data transfer between my servers. Like, all this traffic, this 10 gigabits of iPerf traffic, is all going over this first interface. So, that's the first misconception, Eth-tool, or a similar tool, Windows might show this, various Linux tools might show a higher speed here. But if you're talking between any two clients, the most you will ever get is the speed of one port. And as I said, I won't really demo the second because I'd have to reconfigure my network to demo the second, but it's true as well. And hopefully, as I explain how LACP is determining which slave link to use, it'll become clear why both these are misconceptions and why it works the way it works. So, LACP operates based on a transmit hash policy. In my case, I have it set just to layer 2, but there are actually several options here. Widely supported, you have layer 2, layer 3, layer 2 plus 3. You have those 3. Some exotic switches, some exotic implementations might support layer 4, which will get around these problems and these misconceptions, but my switch and my NICs don't support that, so I don't think it's very, and mine are very common, so I don't think it's, a very widespread solution. Really, if you're using LACP in your home lab, you're probably going to run up against this limitation. So, how this hash policy works is that whenever an Ethernet frame is to be transmitted out an LACP interface, so, if it's the server with the 2 ports transmitting it out to a switch or to another client, or if it's, a client coming in, it hits a switch, and then the switch is the thing that has the LACP bond to the server, wherever that transmit over the LACP happens, the device runs a hash. And depending on this value here, layer 2, how it works is it takes the sender MAC address and the receiver MAC address and uses those. If it's layer 3, it takes the IP addresses. If it's 2 plus 3, it takes the MAC and the IP address, But in any case, it takes the send information of the frame and the receive information of the frame. Now, for this, you got to remember that MAC addresses, IP addresses, all of that, really what they are, what you see on your screen is just a human-readable representation of what is a binary number. So a MAC address is a 48-bit binary number. An IPv4 address is a 32-bit binary number. An IPv6 address is a 128-bit binary number. But in all those cases, it's a binary number. So this hash algorithm that the hash policy runs will take, whatever values. So in my example, layer 2, it'll take the sender and the receiver MAC addresses. It'll take those big, long binary numbers, squish them together, and do an XOR across all of those bits. Now, if you're familiar with binary and XOR operations, you can probably see where this is going. No matter how many bits you put into this hash function, you are going to get out a single binary number. It will either be a 0 or a 1, because you're XORing each bit to each other. So, no matter what you put in, you're going to get either a 0 or a 1 out. And so many people don't know that that's how it works. But that's how it works. And then it uses that number, that 0 or that 1, to determine which slave interface to send the packet on, either the 0th or the 1st. So here you can see how both misconceptions happen. I'll start with the second misconception first because it's the most obvious. If you have more than 2 ports in your bond, it's impossible to select more than those 2. The XOR of no matter how many bits is always going to be a 0 or a 1. It'll always pick port 0 or port 1. It'll never pick port 2 or port 3 or port 4. So you can add as many ports as you'd like, but they're only going to be useful for failover. They're not going to give you any more performance, no matter how many clients you have. The first misconception, well, for that we can look at our servers and we can actually see why that's the case. If I do the procnet bonding output of these, machines, ignore that I ran that twice, I already have it here. So, HV1, its virtual MAC address for the bond is going to be the first interface. So it's going to be this number here, this MAC address. And the second server, it's going to be this MAC address. Now, because, these are binary numbers, we really just have to look at the last digit, and we really just have to look at whether that digit is even or odd. So, this MAC address ends with 8. That's even. That means that this will eventually XOR down to a 0. Keep that in mind. This one ends in a 0. Well, that will XOR down to a 0. Both of these, when they're transmitting, will pick port 0. And that's why all of the traffic went out our first slave interface here. it always picks port 0, and it only picks one port. It doesn't pick port 1 for one packet and pick port 2 for another packet, because it's running them through this same hash function every time. And the MAC addresses aren't changing. They're always the same MAC addresses. And that's why, single client, you're only ever going to get one link's worth of traffic, because it's only ever going to use one link. Hopefully that helps explain, why this is a misconception, why people, might think that it works a different way, or why they might think that, because tools like ftool report this very poorly, might get this misconception. Well, this is, how it actually works and why that isn't the case. With LACP, you're really only ever going to get one port speed per client. Where the big benefit of it comes is when you have a one-to-many relationship. So you have a server with a lot of clients, With one client, you're only ever going to use one link. It's useless. If you have two clients, you're really, 50-50 there. If you look at the MAC addresses, you might find, oh crap, they both end in, an even number. So they're always going to both hash to the same value. You're not going to get a benefit. Maybe even 3 clients, you might run into that situation. Or you might get lucky, one might have an odd number, and it will, pick the other interface. But really, with such a low number of, clients, you're really just, highly unlikely to get true load balancing between the ports. However, if you had 20 or 50 or 100 clients talking to that server, well, then the law of averages kicks in. And at that point, you're very likely to be balancing quite close to evenly between the two ports. And that's where LACP really shines. So, if you're in a home lab, you only have 2 devices, LACP is probably, not worth it for performance reasons. It is worth it for load balancing redundancy reasons, which is why even I use it, even though I have 2 or 3. I have 3 servers here. I know that they won't necessarily always get more than 10 gigabits, but I know that if I unplug a link, it will still work. But if you're just connecting your desktop to your server, don't bother with LACP. It's not worth it to you. You're better to just buy a faster NIC. Thanks, and have a good one.